Let's look at this problem. Miss Blackwell gives an exam to 2 classes. The mean of the scores of the students in the morning class is 84. The afternoon class mean score is 70. The ratio of the numbers of students in the morning class to the number of students in the afternoon class is 3 to 4. What is the mean of the scores of all the students? And in this problem, one thing we need to be careful is we don't want to take a simple average of these 2 numbers. And we have to use this information because the number of students in both classes are not the same. Therefore, we have to know the number of students. I guess most of the students may understand this, but just in case some students don't understand it, you can think about it in an extreme way. Let's say there are 1 million students in the morning class, and the average score is 84, and there is only 1 student in the afternoon class, and the average is 70. Then you shall understand that the average in both classes shall be very close to the number of 84, right? And vice versa. If there are 1 million students in the afternoon class and only 1 student in the morning class, then the average should be very close to the number of 70. Therefore, you understand that the number of students in both classes do matter. Okay, so this is just to confirm that we need to know the number of students in both classes. And for this particular problem, however, especially for a multiple choice problem, we don't have to know the exact number of students because we know the ratio already. And then we can just use the ratio or the fraction directly. We can just assume the number of students in the morning class is 3. And the number of students in the evening class is 4. And this shall give us the correct answer. I think I mentioned this in my other videos. Whenever you have a problem of mean or average, the thing you really need to consider is the sums. Then we know that the total number of scores in the morning class is 84 times 3. With only 3 students, right? And the total scores in the afternoon class is 70 times 4, right? And when we sum up these 2 total scores, this is the total score of all students. Then this number divided by the total number of students, that'll give us the average of all students. So that's 3 plus 4. Let's simplify this expression. So we have 7 on the bottom. And the one thing we got to realize is that this 84 and the 70 are both multiples of 7. Then we shall not do the multiplication first because we can simplify the numbers. So this is 84 times 3 plus 70 times 4. So let's cancel the 7. We have a 12 here. And cancel this 70, we have a 10 here. Therefore, the final answer is 12 times 3 plus 10 times 4. That's 40. So the final average score of all students is 76. So this is our solution. And we want to choose C, 76. What if this is not a multiple choice problem? In that case, we have to be more rigorous. We can't simplify this problem by assuming the students are 3 and 4. We can't do this. So to solve this in a more rigorous way is also quite straightforward. It's almost identical to this with only one extra little step. And that is this. We assume the number of students in the morning. We set this. The number of students in the morning is 3K. And the number of students in the evening class is 4K. So they can be any multiples of 3 and 4. Then we'll still do the same thing. We'll have 84 times 3K plus 70 times 4K. This is the sum of scores of all students. And then we divide this number by the total number of students, which is 3K plus 4K. That'll give us the average score. And then you probably realize that we can simplify this expression by canceling out these factors of K. We just divide a K on the top and on the bottom. So all these K's go out. Then this expression is simplified to the same expression in here. And the rest of the solution will stay the same. So this is the rigorous way to solve this problem. And you should get a perfect score if you do this. Alright, if you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.